Okay, hi everybody. The project that we've been working on this past term is called Bark, which is a virtual pet AR application. I'm Devin. I'm the project manager and lead AR. I'm also secondary UX.
Hi, I'm Leanne. I'm the lead UX, but also the secondary UI.
I'm Lilly. I'm the primary UI and secondary content.
I'm Mel. I'm primary AR and secondary UI.
I'm Brittany. I mainly did content management and a bunch of UI.
Kelsey, and I'm primary AR, secondary UX.
Okay, so we are an augmented reality app that aims to provide a virtual animal companion to our users, offering entertainment and emotional support. We want to give our users the opportunity to continue creating memories with their pet wherever they may be through their extended Bark life.
The problem we want to address is that there are many people who can't own a pet due to living restrictions or those who are allergic to them. With this application, the dream of owning a pet can become the closest thing to reality through augmented reality. Anyone can interact with the pet wherever they go without having to deal with allergies or similar issues. The application isn't just specific to these problems, though, as there are many others, such as dog owners who are frequently away from their pet and need something to fill that loneliness, people who are thinking about owning a pet but want to experiment how to take care of one, people who are seeking entertainment in the form of pet companionship but want more than just a 2D experience and don't want to deal with real ones. This application is for everyone.
Our first phase of research and design is alpha, and here we will be covering the UX, UI, and AR portions of this section. So beginning with our survey and target audience, the UX team was responsible for researching how a user's entire experience is transformed from a mobile application to an AR application. The UX team focused on usability test scripts and creating card sorts to better understand our users' thought processes about how they interpreted Bark's UI. From the preliminary survey, we found that a large amount of our surveyors were ages 18 to 24 and were interested in having some sort of app like Bark due to their love for pets. We asked them questions about what they would like to see within an app like Bark and took their responses into consideration when developing our customization and interaction screens.
So now I'm about to talk about the UI general process and wireframes. So the UI team worked primarily in Figma, constantly iterating on designs and prototypes to meet the deliverables our team set at the beginning of each bi-weekly sprint. Every design decision made throughout the entire process has been based on research on the market's leading trends, as well as results from user testing conducted by the UX team. There was a lot of close collaboration between the UI and UX team, such that they both functioned as quality assurance for each other's work. This constant flow of communication was key to successfully realizing the needs of our users within the timeframe we were given. Over the course of 6 months and 5 different prototypes, we were able to reach our goal of a high fidelity Figma prototype. So we wanted one of the main selling points of Bark to be customization. With this in mind, in our alpha wireframe flow included different aspects that could be customized, such as name, breed, size, fur, and behavior. First, the users asked for their name, then they select their pet breed, then size, then color. In this section, they pick a fur pattern they can adjust the colors with using a slider. If they don't see any furs there's a camera button to upload a photo of their existing pet. Next, they can adjust pet behavior with a few different slider options, and lastly, they name their pet. As you can see, decisions had not been made yet on final content such as breeds, fur patterns, and behaviors. The purpose of this prototype and user test was twofold. We wanted to see if this creation process was intuitive to a user and felt quick and clean. We also got the chance to ask users what breeds, pet fur patterns, and behaviors they would be interested in seeing.
The team extensively researched AR platforms and designing for AR before beginning any development. The platforms investigated were Lens Studio, Adobe Aero, Spark AR, and Unity. Lens Studio was the first platform that we experimented with, but after a few sessions of trial and error, we decided that Lens Studio's interface was too confusing and was taking way too much time to even begin basic development. We then moved to Adobe Aero, which we heard good things about, but the platform kept crashing since it was only a beta version. Finally, we moved to Spark AR, which is where we spent the first half of our project following tutorials and creating our basic interface.
So now we'll be talking about our second phase of research, design, and development, which is our beta. And again, we'll be covering UX, UI, and AR. So one of the most important aspects that the UX team rigorously worked on was to make sure that our users understood the icons that were being presented to them and what our users' mental maps were when grouping certain icons. Using optimal sort as our platform to conduct the card sort tests, we were able to conduct a completely unbiased test, allowing our users to make groups however they pleased, resulting in our team receiving data on how to group our icons. After our card sort test, we found that a lot of our users grouped their options into groups of 3, while we originally as a team had the options in groups of 4. We took this data into consideration and took the most popular groupings of 3 to implement into our interaction page. Our team then tested users with the purpose of collecting knowledge on icon meaning. We also asked about the visibility of the icons and the general understanding of the homepage. These results were used to help create a more intuitive AR interface.
The overall flow of the pet creation goes from user name, breed, size, fur, eyes, behavior, pet name, and then finally the interaction screen. This process is based off of user feedback from our initial survey and card sort, as it reflects similar task flows within other applications and what makes more sense to our users. We shifted where the menu was located and acted. While it seems we have a set flow, when this app is fully developed and functional in its own native app, it would allow users to move easily throughout each of the sections as they please. This allows users to see what is ahead in a customization and how many sections they may need to visit before finishing making the pet. The ability to edit pet eye colors was also added to the interface, along with changing the size from 3 buttons to a slider as we further refine the customization process.
We decided to begin AR development in Spark AR, which is a platform used for Instagram and Facebook filters. The main reason we decided to begin in Spark AR was because of its ability to easily test our project on the Instagram and Facebook apps. Our initial progress in Spark AR consisted of creating basic button setup by following multiple tutorials. These tutorials allowed us to create a basic interface with functioning buttons and allowed users to change animation states on the screen. So now this is our final phase of design and development. Again, we'll be talking about the UX, UI, and AR portions in this section. The priority matrix was developed after an analysis of the team's user testing data to better organize our data that was collected. The data was organized by level of effort and level of importance. This was then used to determine what changes were most necessary to tackle when making adjustments to the prototype.
So for our final, we updated the style guide. User testing results on previous iterations of our prototype told us that there were problems with the colors we selected. Our previous color scheme was primarily monochrome blue. And as a result, our results told us that our users wanted a more diverse color palette. Our previous color scheme also did not pass color contrast tests, so there was a visibility issue with our application. For our final style guide, we updated the color palette to include a wider range of blues, greens, and white to create the diversity and contrast our users needed.
So once we were able to refine the exact flow and design of our application, we then began to focus on micro interactions to give our users a smooth experience when navigating throughout the app. To plan for this implementation, the UI team developed a series of IX flows for potential micro interactions that could be implemented. These micro interactions span from transitioning a loading screen for users to customize their own pet to the smallest little interactions that would allow users to toggle switches. The team also developed separate screens to show the different states that the micro interaction components would go through. After designing these screens, the triggers, rules, feedback of each micro interaction were documented into one document.
The AR team decided to move into Unity for the second half of the project because working in Unity would allow us to build out a much more complex button interface. This would give users the option to choose subcategories of our buttons to really interact with their pet and perform desired interactions. Spark AR was great for practicing projecting the avatar and getting the feel for the interface, but it did not allow for much more complexity to be added to our buttons. The team needed a platform where opportunities for tapping and selecting could be expanded since our buttons on the AR screen open to menus. The team researched developing for AR in Unity before moving into the software to make the transition way more seamless. We collected a few tutorials to follow in Unity to begin understanding the interface and how to create an AR build within Unity. Also, Unity has the ability to create an iOS build that can be opened in Xcode and run on a personal mobile device. To test our project, we would compile and run our build on a personal device, taking note of any changes or adjustments that would be needed to be addressed in our next development session.
Working with tutorials and previous knowledge from Spark AR, the team was quickly able to adapt to the Unity interface. The team produced their first build which recognized horizontal planes in AR. This plane detection would allow a 3D model to successfully be placed in an AR environment. The team then began working towards adding our 3D Husky model to an environment upon detection of a horizontal plane. We first used a sphere as the 3D model, building a prototype that allowed for the placement of a sphere on tap. Next, the team imported the 3D Husky model that was purchased for the project and worked towards placing that on the plane. This new build allowed the Husky model to be loaded upon detection of the 3D plane, but the Husky was halfway below the plane and was facing the wrong direction. The following few builds worked towards multiple goals, including adding buttons to the interface, adjusting lighting, and fixing the orientation of the Husky model. The team was able to easily link in the styled buttons for the next build and bring the Husky to the plane level. Finally, the Husky rotation was fixed to face the camera, and all that was left was to develop button functionality. The Husky model had built-in animations that the team wanted to use. The goal was to have the Husky model playing an idle animation. To do this, the team needed to work an animator to link the animations to the Husky avatar. Adding functionality to the buttons has been the most complicated part of this build in Unity. The team successfully added an open state to the main 3 buttons on the home page. This was done by creating a child element of the button that holds the open menu image. This element was then turned off. Next, a script was written to check if the element was visible or not visible on click, turning the element on if it wasn't visible and off if it was visible once the button was clicked. This script was then linked to the button's built-in on-click function. This allowed button menus to be opened on click. All right, so just getting into our final thoughts. The main challenges of this project were working in AR and the time frame. AR is a new technology that this group had not developed or designed for. This required the team to do a lot of preliminary research and some of the team to learn how to develop for AR. This new technology coupled with a short time frame definitely posed a challenge for the team.
What we were able to produce in this time frame was a high-fidelity Figma prototype for the pet creation. We finalized this design based off the data collected through extensive user testing, building semi-functional prototype that allows us to customize their pet. Through Unity, we produced an iOS build of an AR functionality that allows limited interaction with the pet.
Here are our takeaways. Creating Bark showed the team how important user testing is. User data was essential in iterating on and perfecting our designs. Because the team developed in Figma, we were able to constantly conduct user testing and receive meaningful feedback to work off of. After working on different AR platforms, the team learned that Unity is the best option for AR development. Though Bark did not turn out as expensive as originally proposed, Bark still turned out to be a success. We are very proud of our hard work, especially the fact that we learned how to use a new software to build a functioning app from scratch. Bark successfully fulfills our initial goal of providing emotional support and entertainment and companionship through a fun, interactive experience. The extensive user testing and research that went into this build has created a great stepping stone to continue developing Bark to its fullest potential in the future.
Thank you all so much for listening. And if there's any questions, our team would be happy to answer them for you.